defining and discuss the students' t distribution. Solution: let W denote a random variable that n is equal to 0 to 1. Let V denote a random variable that is chi-square R. Also, let W and V are the stochastically independent. Then the joint probability density function of W and V say that phi W and V is a product of the probability density function of W and that is of V. Phi WV is equal to curly bracket starts 1 upon square root 2 pi e raised to power w square upon 2, 1 upon factorial r upon 2, 2 raised to power r upon 2, v raised to power r upon 2 minus 1, e raised to power v upon minus v upon 2, minus infinity is less than w is less than infinity, and 0 is less than v is less than infinity, 0 elsewhere. Let us define a new random variable t by writing t is equal to w upon square root of v upon r. Now we use the change in the variable technique to find the probability density function of g1t and the equation t is equal to w upon square root of v upon r and u is equal to v, defining a one-to-one transformation that maps a curly bracket starts w v bracket close, where minus infinity is less than w and less than infinity, 0 is less than v is less than plus infinity curly bracket close, on to b curly bracket starts t comma u bracket close, where minus infinity is less than t is less than infinity, 0 is less than u is less than plus infinity curly bracket close. Since w is equal to t square root of u upon square root of r, v is equal to u, the absolute value of the Jacobians of the transformation j is equal to square root u upon square root of r. The joint probability density function of t is equal to u is equal to v is given by g of tu is equal to phi bracket starts t square root u upon square root r comma u bracket close modulus of j is equal to 1 upon square root of 2 pi factorial r upon 2, 2 raised to power r upon 2, u raised to power r upon 2 minus 1 exponentials square bracket starts minus u upon 2 into bracket starts 1 plus t square upon 2 bracket close square bracket close square root u upon square root r. 0 elsewhere, 0 minus infinity is less than t is less than plus infinity, and 0 is less than u is less than infinity. The new marginal probability density function of the t is given by g1t is equal to minus infinity to plus infinity g of t u du is equal to 0 to infinity 1 upon square root of 2 pi r factorial r upon 2, 2 raised to power r upon 2, u raised to power r plus 1 upon 2 minus 1 exponential square bracket starts u upon 2 bracket starts 1 plus t square upon r bracket close square bracket close du. This is equation 1. Let z is equal to u square bracket starts 1 plus bracket starts t square upon r bracket close square bracket close upon 2, the integral 1 transform to g1t is equal to 1 upon square root of 2 pi r factorial r upon 2, 2 raised to power upon 2 bracket starts 2z plus upon 1 plus t square upon r bracket close raised to power r plus 1 upon 2 minus 1 into e minus e raised to power minus 2z upon 1 plus t square upon r bracket close dz is equal to factorial square bracket starts r plus 1 bracket close upon 2 square bracket close upon square root of 2 pi factorial r upon 2 1 upon 1 plus t square upon r raised to power r plus 1 upon 2, where minus infinity is less than t is less than infinity. Thus if w is n01, if v is chi square, and if w and v are the stochastically independent, then t is equal to w upon square root of v upon r has a immediate proceeding probability density function g1t. The distribution of the random variable t is usually called as the t distribution. Now a t distribution is completely determined by the parameters r and the number of the degree of the freedom of the random variable that has a chi-square distribution.